Hello, and I would like to show you an example using Microsoft Excel of a business application. So let's have a look at this problem. A casino threw in a new twist. In addition to previous offers of option 1 and option 2, 30,000 US dollars 5 years from now, or 25,000 US dollars today with an interest rate that is of 3.5% annually compounded monthly. They are offering to instead give you the option of an annuity, which is option 3, $9,000 today, $4,000 each year for the next 5 years. We want to know which is going to give us the maximum amount of money after 5 years, option 1, 2, or 3. We need to calculate the value of the annuity. We need to use the Excel if statement to make the determination of which is the best option to have the most money after 5 years from the casino. The if statement should contain the Excel max function to determine which is the maximum value, option 1 or option 2. And then if the annuity is larger, we take the annuity. Otherwise, we just print the value that we're going to receive, which is the maximum value. Okay, so I've summarized the data down here in this table. Option 1 is to wait for the $30,000. There's no interest rate or initial value invested or payment. We just wait. Option 2 is to invest the $25,000 and to have a compound interest at an annual interest rate of 3.5%. We don't receive any regular payments. We just let the money grow over 5 years. And then option 3, we get an initial investment of $9,000. Now, that's what they just initially give you. But instead, with an annuity, they pay $4,000 into an account, and then that is compounded. And then each month, they pay a portion of that $4,000. So it's actually $4,000 divided by 12 is the amount paid into an account, so that it adds up to that they're paying $4,000 each year, but in monthly installments with the same interest rate. And then this is the number of times we compound per year, and then again, the total number of years. So let's see how we calculated these values. And I am able to show that the best deal is to wait the 5 years for the $30,000. Now, many people are a little impatient. They just want to take money earlier. But the idea is that let's show why that's the case. So for option 2, we're using the compound interest formula. A equals P times 1 plus R over N raised to the NT. A is the final amount that's in the account here, option 2. P is the initial principal balance. That's how much we initially invest in option 2. R is the interest rate. That's an annual interest rate. It's shown as a percentage. It's calculated in these formulas using decimal. N is the number of times we apply the interest per year. That's the number of compounding periods. So monthly is typically going to be 12 times per year. And then the number of time periods elapsed, that's 5 years. Now notice with the value of an annuity equation, the variables are the same, R, N, and T, except there's an additional value, and that's P, or sometimes called PMT, payment. That's the annuity that's invested. And remember, for this number, we're using $4,000, but we're actually dividing by 12 when we actually calculate this in the formula, because again, we're assuming it's $4,000 over the entire year. So each month, it's 1/12 of $4,000. So I am able to show using either calculations by hand, that is these two, and just taking the $30,000 value, or by using Excel functions that are built in, that option 1 is indeed the best. So let's see what this looks like using Excel. So using Excel, you can look at these formulas. A lot of times clicking on one of these Excel formulas, say right here, with calculating with using a function is best. And that kind of ends the problem. I hope that was helpful, and good luck with your Excel.